My name is Prince Asante. I'm a sheet metal mechanic at DAS Aviation. This is a left-hand outboard flap coming off a Falcon 20. The spar had damage on it. This other spar had damage. The two ribs had damage on it. And we're in the process of fixing it right now. Both spars were completely dented, meaning it did not look like what it looks now. So we had to co-work it. The skin was also damaged, as you can hear. So that needed to be cut out, which is what we did here. So this is the filler that we've made. So the skin is actually chem milled 40 thousandths. So whatever you take out is what you put back in. So we have a 40 thousandths piece here to fill the gap. First thing you have to do in a situation like this is you have to gain access to the part, which entails us taking out all these rivets, as we've done, which will allow you to lift up on the skin. Once you lift up on the skin, you have to be mindful of your underlying structure. You don't want to damage that. You get your sacrificial piece of titanium to put underneath it. Once you have that underneath that, you have your cutting wheel, steady hand, go ahead and cut across. That's what we have here is the cutout. This is what we cut out. And as you can see, no damage is done to your underlying structure. And that's the goal. The main challenge is you don't want to damage it more than it already is. You don't want to add on to the problems. So the main thing is when you're doing a cutout like this is not to cut into the underlying structure. So as we said before, once you de-rivet it, you get a piece of titanium strap to wedge it underneath. This we can scrap all day. This we cannot scrap. So now that it's all cut, you can look at it. We didn't touch the underlying structure. It's still good. There's no added damage. That's one of the key things. You don't want to add on to your problems. So this is going to be our doubler. So we're cutting off a piece of metal, 50 thousandths. Okay. All right. This one piece should do. In this situation, this is a very old plane. I believe this is actually was built somewhere in the 70s. So getting parts with something like this is just, it's not feasible. So the only option is to repair it unless you're gonna maybe go to junkyard or scrapyard to find another piece and hope to God that that's in good shape, which not likely more often than not. So that's why we have to repair it. I don't know how well you can see this outline we have here in the red. This is gonna take place of our doubler. The standard repair is you have damage, you cut out your damage, which is done here. Whatever you cut out, you fill, which would be your filler. Boom. That sits in there. Now you have to tie everything together. This filler and this skin needs to become one. And that's where this doubler will come in. So that's what we're about to do next. We ensure these parts meet standards by following our engineering order, which will inform us of what material to use, what hardware to use, and exactly how to lay out our plan and our goals. These are called Clecos. They're temporary fasteners. They just hold things together for you. It holds that in place, which is what we need. Making sure we're flush all around. All right. So these are number 30 holes. You have a number 30 drill bit, just go to town. Safety first.
How many holes do you have to drill?
This is about 100 holes right now to drill. It don't take too long. Just want to secure the piece together, and you can just go have at it. So now we can remove these. I believe we have all our holes.
What happens if you miss a hole? Does it make a big difference?
Well, yes, because there's a hole. All these holes correspond with something on this flap. So if you're missing a hole, you're going to be missing a fastener. So you have to come back and re-drill it. Now, as we said earlier, your doubler is going to encompass over the cutout and extend out. So roughly 2.6. Measuring out how much room we need to make our doubler, and then we're going to trim off the excess. Removing everything, we're going to trim off the excess, and that should give us our doubler. Once I'm done with my portion of this sheet metal job, our inspector will look at it, making sure everything meets standards in the engineering order. And once that's done, we send it to paint, and they paint it, get it ready, send it back to the customer. Put your feet. If it's an inch off on an accident, that's unfortunate. You're gonna have to start all over. There's not really much room for forgiveness. You gotta have it dead on. I take pride in what I do, so at the end of the day, people's lives depend on the things we do here. So you have to take pride in what you do, and you do it to the best of your abilities, and you have to be honest, have some integrity with what you're doing. So, and, you know, you can go home knowing that you did the best you can and you didn't put anybody at risk. Well, we're gonna Cleco everything together, and we're gonna put it on the part and make sure everything fits accordingly. So everything fits as it should. Your filler is underneath. This is your doubler, which will tie everything together. And there's gonna have to be a lot more holes needed to be drilled to secure everything together, which are called your fill fasteners. Pretty much just gonna go in sync in that row all around. So, but the first step is done, getting your doubler started. That's that. Let's flip this over so they can see. Tell you what we did already. So these are the old ribs, as you see, damaged. So it got fabricated, these two. So it got fabricated, we located, we drilled it, it's installed. The doubler that you guys had seen earlier, that's already been shot together, all riveted. So So the next step for us is to start shooting these ribs onto the doubler and carry on from there. So what we're gonna do now is just continue shooting the rivets. It's a little noisy, so I don't know if you're ready. Started in the middle. Just work our way out. All right. Yep. A little more. Yep. Yep. Ease up just a hair, Alex. Yep. A little bit. That looks good, bud. Yep. Yep. Good. Yep. Now you're gonna need more. Protecting the part. So getting some tape so we're not riding in the radius when we go to buck the rivet. Touching up the countersinks. Keep them nice and flush.
My name is Brock Wilkie. I'm a maintenance technician here at DAS Aviation. These are the thrust reverser doors off of the Challenger 300, 350s. We are removing the corrosion from the inner door skins. So on these, they're at the back of the engine. All the exhaust comes through them, so there's a lot of carbon, a lot of dirt, a lot of debris. And as the aluminum is exposed to all them harsh chemicals, it starts to corrode. So first thing we do is we sand off all the paint that's on the inner door. After that, we come in here and we inspect it and we circle all of our spots where we found corrosion. It's probably hard for you guys to see, but you know, you can look right there and see there's a little bit there. We try to go through and we circle everything, and then once you blend it, we sand it. Sometimes you can see it better after you sand it, then you blend it again, and you just keep moving. After that, we come in, we blend it. So we use a die grinder with a Scotch-Brite pad to get the corrosion out, And then once we're done with that, we get a DA with some sandpaper and we sand it all smooth so it's a nice even contour all the way through. What you're really trying to do is get all these blend marks out because you had to blend out the corrosion and it leaves these scratches. So what you're trying to do is get it back to the same uniform color all the way through and make sure it's nice and smooth without any blemishes or scratches or marks. Sharpie and a magnifying glass so that you can really look in there and make sure that there's no corrosion left. And then you need to be able to grit it off, and then you also need a UT gauge to check thickness throughout. No, there's not a lot of challenges. The big thing is just making sure that you get all the corrosion. Sometimes when you get a nice mirror finish like this, it's hard to really see if all the corrosion's there. We can take it, we can repair it, and we can get it back to you quicker. It's cheaper than buying a whole new door, and then parts availability. You don't even know if you can buy the door. And then also it's more efficient, it's faster. You don't have to wait for them to try and build you a door. And then whenever I'm done with it, I'm gonna hand it off to our quality department and they're gonna inspect it. And then once they go and they give the okay, then we take it down to paint.
We blended the doors. Now we got to go through and check the thickness of the metal. Make sure we didn't go too low. The red marks are where there's structure on the backside that you can't see. So there's different zones. So you have 5 different zones, and that's what the red squares are, because there's different tolerances. 96, 94, 94, 99, and then you got one left, right?
Yes, sir.
62, 93, 94, 94, 95, want it inside or outside? I'll go on the outside of it. 69. And one more. After this, we go through and check all our measurements and make sure they're within limits, and we send it over to paint.
My name is Dave. I'm a paint technician, and we are prepping the TR doors for the primer and paint. So right now what we're doing is we're just getting through, we're sanding all the product down, getting all the shiny stuff off so the paint will adhere to the part well. So we're just going through and sanding everything. Process, I would say, takes a good couple hours, probably an hour per door, so 4 hours. And then after this is done, we'll mask everything off that is not going to get primer sprayed on it. And then blow everything off, we'll wipe everything down, put it in the booth. The DA, where the DA can't get into the corners, we're just hand sanding, going back through and making sure you get all that off of there, you know. This one over here would be a completed sanded part. This one will be ready for the taping process, and then pushing it in the booth and getting primer put on it.
My name is Edison Weiland, and I am a composite and paint technician for DAS Aviation. Right now I am masking off this door for paint on the outside. We are going to paint the inside with primer. You don't want the paint to get on the outside of this part because the primer is going to be green and this is white. You don't want to see white on the outside. So after we sanded everything, we masked it. Now it's just wipe it down and ready for paint.
So we are mixing the epoxy pre-treatment, and this is the first stage of spraying the TR doors. We're going to do a pre-treatment, and then we do a primer on top of that. So just mixing a 1-to-1 mix ratio here.
Hi, my name is Rachel Thompson. I'm the lead paint technician for DAS Aviation.
Basically, as she's spraying, she's just trying to get full coverage on each part. And this is what is called a epoxy pre-treatment, and what this does is it helps with corrosion and adhesion of the rest of the paints as it's getting layered on.
I just got done spraying the SP350 beige primer on these TR doors and beams. I have to do 2 coats of the primer, then it has to cure for a minimum of 104 degrees Fahrenheit before I apply the blacktop coat.
My name is Mike Logsdon. I'm a lead composite technician at DAS. Today we're working on an outboard trailing edge from an elevator off a Gulfstream G5 1-inch by 1/2-inch puncture that went through the trailing edge skin of the elevator. There was a through puncture on this skin, so we removed it from the assembly, routed the hole out till the edges were clean, and did a scarf repair. And on the inside, we laid up one layer that was about 1 inch wider than the hole, put a fill ply in the middle, and then stepped it out on the outside to give it a little bit more rigidity. We put a repair ply on the inside, a filler where we routed it out, and then we stepped out the skin on the outside, like taper sanded it smooth so we could add more material without adding any additional thickness. And once that's cured, you're going to want to come out and fair sand it, make sure you don't have any lifted edges. For this repair in particular, tools that are essential are going to be your sanding tools like a DA, die grinder, a rotary file to clean out the puncture. We're going to want clamps to make sure we get good pressure on the wet layup once it's applied to the part. We're going to want our PPE, like our respirator. One challenge that we faced with this repair was figuring out how to get good pressure on the wet layup once we got it down. The part's too fragile to bag and it could crush itself under vacuum. So what we ended up doing was making a wedge that fit on the inside snug so we could use clamps and a call plate on the outside. So now I just got to mix some epoxy up. So everything we mix in here is by ratio. So this particular epoxy is 100 to 30, but I don't need quite that much. So I'm going to split the ratio 50 to 15. Yeah, so this will give it like some structural properties. So as you could see, like when I was cutting it, the carbon fiber is pretty flimsy on its own, but it combined with the epoxy, it's pretty strong. So make sure it's all combined really well. This is how we impregnate the fabric. We do primarily wet layups here. Inside this plastic film. Close it up. Wet it out. Just push the epoxy through the weave. Now, when you're getting ready to lay fabric on this, you kind of want to wet the part out a little bit too. Spread a thin layer over it. So I like to cut the edges off. I just cut a little bit more than I need so I can make sure we don't get any of this frayed material in there. We want the weave to be intact so the part's strong. When you're looking at it, you can see the way the weave runs. If you look at the part, you can see the way that it's running. Anytime you're laying material up, you want a 45-degree offset. Kind of helps the part, it makes the part stronger. It's important to repair versus replace in cases like this because of cost. It'd be substantially more expensive to replace this elevator than it would be to perform this repair. We ensure parts meet standards before they leave here by strictly adhering to our quality processes in the building. We document everything that comes off. We document everything that goes back on. In this particular instance, we're using mechanical pressure versus vacuum pressure. Because of how thin this skin is, you can see if we tried to bag it, we would probably damage the part. So I've got a wedge prepared that matches the inside of this skin. Place that in there. Some release film at the top. And this is a call plate. It'll help it stay flat where we want it. Once we finish the composite repair, it'll get a QA inspection before we throw it together. It'll get a follow-on QA inspection final, and then we'll transfer it over to paint. It's a good feeling knowing that the work we do here keeps airplanes in the sky. It's fun work, and it's always nice when you can meet a tight turnaround time that makes the customer happy. So you get it all set up. I like to go low heat first. You want to check your temperature with a pyrometer periodically to make sure you don't get too high. You don't want to burn the epoxy. So it'll be about an hour at 150 degrees from the lamp. If you don't use the lamp, it could take up to 7 days for a total cure. There's other curing options too. You can throw it in an oven, an autoclave. You can use a hot bonder. For small repairs like this, it's pretty easy to use a lamp. This is just a small example of the composite capabilities we have here at DAS.